Hello everyone, I am Indrajyoti Gaine. I am a PhD student at Department of Metabolic and Statistics, IIT Kanpur. I am a PMRF fellow right now. Before that, I was a CSR fellow, and I have cleared my CSR net with 108 rank. So from the last class, we have discussed about straight lines, and we have in the last class, we have discussed the equation of the straight line. So in case, let's have some recall. So first, we have discussed about the straight lines which are parallel to the horizontal or vertical axis. And we have next we have seen that when we know the slope of the straight line or one point on that straight line, then how we can derive the equation of the straight line. And also, if I know the angle of inclination of the straight line with the positive real axis, then also how we can find the straight line, equation of the straight line using one point on the straight line. That also we have discussed. And at the last we have discussed about this thing, this one, where we have seen that we only know about 2 points on that straight line, and using only the 2 point, we can find the equation of the straight line. And also we have deduced some simplification of simplification. Say we can say that some different kind of representation of the straight lines which are passing through either axis. Okay, and also we have discussed one thing that if a straight line passing through both the axis, and usually if it is not horizontal or vertical, well, if it is not parallel to x axis or y axis, then it must somehow cut either axis. That is, both the axis. So from there, every straight line, every equation of the straight line can be modified into the equation of the straight line, which is in this form, like x by a plus y by b equals to 1. That is the form of this intercept form, which you can call it as a intercept form. So every equation of this straight line can be put into this intercept form. Now, today we will see some example of these straight lines or the equation of the straight lines and how we can solve this kind of questions. So let us start with the first example. Find the equation of the lines parallel to axis and passing through minus 2 comma 3. Okay. So what they have asked that they will find the equation of the straight line which is parallel to the axis and passing through minus 2 comma 3 point. So, but first draw the axis. Suppose this is our y axis and this is our x axis. Okay. So where will be the point minus 2 comma 3? Minus 2 will be here and 3 will be there. So this point will be the point minus 2 comma 3. Next what they have asked that this will be parallel to the axis. Okay. Now if it is parallel to the x axis, then the straight line will look like this. So they haven't mentioned that parallel to which axis. So we can assume that this is parallel to x axis or it is parallel to y axis. If the straight line is parallel to y axis, then it will look like this, right? So we will write here both the cases. If the straight line is parallel to x axis, parallel to x axis, then the equation will be parallel to x-axis means which one? This one, this one. And for that, our y equals to 3 is fixed. Okay. So the equation of the straight line will be y equals to 3. Or else we can put any point on this straight line and we can find the equation of the straight line, because any point on the any arbitrary point on the straight line will be like here, and that will be like x comma 3. Okay. So from there also you can find the equation equals to x equals to like this. Yep. Now if the straight line is parallel to, if the straight line is parallel to y axis, then equation will be x equals to -2. Okay. Why? So just remember one fact, that whenever the straight line is parallel to x axis, then our x can vary, but y is fixed, right? Parallel to x axis, that is, our x can vary, but y will be at a fixed point. So that fixed point is the our equation of the straight line. Similarly, if the straight line is parallel to the y-axis, then our y coordinate will be fixed. So only it can vary the x coordinate. So x equals to -2 will be the equation of the state. Okay. Next, find the equation of the straight line passing through -2 comma 3 and with slope -4. So what are the information we have here? So the equation will be, the straight line will be passing to the point -2 comma 3, and it has slope equals to -4. So we know about the slope of the straight line and point on this straight line. So for that, we will go back to our equation of the straight line. Yeah. So here we will use this equation. Why this equation? Because we know about this m, we know about x1 and x2, right? So if I put this x1, x2, and m in that equation, we will find the equation of the straight. So the equation of the straight line will be y minus 3 into m means -4 into x plus 2. Why plus 2? Because x minus of -2. So this will be given as x plus 2. So if I simplify it, I will get y equals to y minus 3 equals to -4x minus 8. It will further give us y plus 4x plus 5 equals to 0. So this is with the equation of the straight line. Or also we can we can rewrite this equation in the form of intersecting form. Like if just from here we can rewrite it like this. So the equation is 4x plus y plus 5 equal to 0. So we can change this plus 5 to the minus 5 term. And this will give us like this, which will further give us x by minus 5 by 4 plus y by minus 5 equals to 1. So this will be the intercepting form of this straight line. So depending upon the requirement of this question, you can rewrite your equation of the straight line in that form. But in general, if they didn't ask anything, then this much is sufficient. Okay. So let's go to the next question. So the next question is, find the equation of the straight line that passes through the points 1, 1 and 3, 5. So here we can use this equation, this third one. Why the third one? Because here we know about 2 points and we have no other information. So here we know only about 2 points on this straight line. So we can only use that formula for the case where we know only the 2 points on this straight lines. For that, what I can do, so that let us rewrite this equation of this straight line passing to the point x1 and x2, x1 y1 and x2 y2, x1 y1 and x2 y2. If a straight line passing through these 2 points, then the equation will be of the form y minus y1. This is equals to y1 minus y2 divided by x1 minus x2 into x minus x1. Okay. So here, let us consider x1 y1 are 3 and 5 and x2 y2 are 1 comma minus 1. Then we can replace this x1 y1 in this equation by this numeric values. So what I will get, so y minus 5, this is equals to yn minus y2, that means 5 minus 1 divided by x minus x2, x1 minus x2, that is x1 is here 3. 3 minus x2 means 1. Okay. This into x minus 3, right? So we will get y minus 5. This is equals to 5 minus minus 1, that is equals to 6. And 3 minus 1, that is equals to 2. So this will give us 3 into x minus 3. Okay. Now if I simplify this, we will get y minus 5 cx minus 9. So we will get cx minus y minus 4 equals to 0. Okay. 3x minus y minus 4x equals to 0. Or like one can rewrite it like y minus 3x plus 4 equal to 0. Both are same. Both the equations are same, and you can write it in your own pattern, in your own choice. Now, one may ask that if I consider x1 y1 equals to minus 1 comma 1 and x2 y2 equals to 3 comma 5. That is we can, if I replace the position of x1 y1 and x2 y2 in the equation of the state line, what will we get? Suppose our x1 y1 is x1 y1 is 1 comma minus 1 and x2 comma y2 is 3 comma 5. Okay. Now, using this information, we rewrite the equation. So the equation will be y minus y1. So y1 is minus 1. So this will the first part. Then y1 minus y2 divided by x1 minus x2 into x minus x1. Now let's simplify it. Or we will get y plus 1 minus 6 divided by minus 2 x minus 1, that is equal to 3 into x minus 1. So again, it will give us 3x minus 1. So simplifying this, we will get 3x minus y. Sorry, it is not 3x minus 1. This will be 3x minus 3. So ultimately, we get 3x minus y minus 4 equal to 0. So from here, you can clearly see that whether if you are considering x1, y1 to one point and x1, x2, y2 another point, both the equation will give us the same expression. So both the way you can get the same answer. So it is not depending upon the choice that you will pick it is x1, y1 or it is x2, y2. That doesn't matter. Let's go to the next question. The question is, write the equation of the lines for which tan theta equals to half, where theta is the inclination of the line, and y intercept is 3 by 2, and y intercept is 3 by 2. So from the question, what we know? We know about the slope of the tangent, or slope of the straight line, and one point on that straight line. So easily, you can use the y-intercept form of the straight line, because this is given that the straight line intercept the y-axis, y-axis by at some point. So we can clearly use this y-intercept form, y-intercept form. But even though you don't use or you forget the y-intercept form, though then also you can use the equation of the straight line and you can get the answer. How? So you can try for y-intercept form, but I will write it in general form, just like using a 1 point, using 1 point in a straight line, just by using 1 point on a straight line. So if this is our axis, this is x-axis and this is y-axis. And what they are saying that y-intercept is 3 by 2. So the straight line can be like this. Suppose the straight line is like this. Okay. Suppose I have no idea that how it look like, but yeah, the tan theta is positive, so the theta will be some acute angle. So that's what I have maintained here. So this will give us the theta. So it will be acute angle. So tan theta will be this like. And what the extra information we have that y-intercept is 3 by 2. So it intercepts the axis y at 3 by 2 distance. That is, this point will be 0, 3 by 2. Right? Now, we know the equation of the straight line will be of the form like y minus y1 into m into x minus x1. Right? So we can just put this m equals to half and x equals to x1 equals to 0, x2, y2, y1 equals to 3 by 2. So let's put equals to half x minus 0. This will further give us 2y minus 3 equals to x. This will give us x minus 2y plus 3 equal to 0. Right? But this is equation of the straight line. But how we can write it as in y-intercept form? So just like put the y there and you can get the form. But also you can use the y-intercept form formula and you can get the same answer. Like here, what we had? Y equals to mx plus c. Right? Y equals to mx plus c. So what is mx and c here? So write it y equals to mx plus c. Now what is m? M is our minus, a minus or plus out, a plus out. Minus a plus, sorry, plus c is 3 by 2. Plus 3 by 2. So again, what we will get? 2y is equal to x plus 3. Right? And then we get x minus 2y plus 3 equal to 0. So whether you are using the y-intercept form or we are using the simplified equation of the step line, that will not matter, but you will ultimately get the same answer. And I will recommend that you don't recall too many equations for different forms. Just try to recall a general form or some simplified form, and you can reduce all the other forms. Like if you know about the case where the straight line passing through two distinct points, and then just using that only you can do or you can manipulate other equations. Okay. And simply from here also you can see that how we can get the equation for the y-intercept from or x-intercept from. Like if in the case they have given that line of inclination line which has inclination of half and then theta equals to half and the y-intercept instead of y-intercept they given have x-intercept form like x-intercept is 3 by 2. So then in that case that straight line will cut the x-axis at this point, and this point will be like 3 by 2 comma 0, and you can use this as a point on the straight line and you can get the answer. So only by using only this one formula you can get almost one. And if you have 2 point on a straight line, then you can find the value of n especially from this using that 2 point. Okay, next question is find equation of the straight line which makes intercepts -3 and 2 on the x and y axis. Respect. Okay. So what they are asking is find the equation of the straight line which makes an intercept of -3 and 2 on the x-axis and y-axis. So let's draw the axis first. Okay. And the straight line will be like this. Oh, sorry. Let's find the point first, then we can clearly see. So the straight lines will be like y-intercept is -3. So -3 will be x-intercept will be -3. -2 will be like here. Right? And y-intercept is 2. So 2 will be somewhat like here. So now y-intercept and x-intercept means that along the axis 2 step or along the axis -3 step. Okay? So the coordinate of this point will be -3, 0, and this coordinate is 0, 2. So from here only we have obtained the 2 point on this straight line, right? So if I draw the straight line, how it look like, right? Now recall that we have discussed about the intercept form of equation of the straight line like this, like it was like x by a plus y by b equals to 1, where a equals to -3 and b equals to 2, right? So if I put this, what I will get, x by -3 divided by y by 2 equals to 1. So ultimately it will give us 2x minus 3y plus 6 equals to 0. Just you need to do the required calculations. Okay. Now somehow you forgot this form. Somehow you forget this form. Then how can you manipulate this? So just use that these two are a point on the straight line. 0, 2 and -3, 0. These two are 2 points on a straight line, and you can yourself try that how the equation will look like. Okay. Now in the last class, in the end of the last class, we have told about that how we can, what will be the cases for a comma 0, 0 comma minus b minus a comma 0, or like this. That like depending upon the slope of the tangent and which coordinate it is lying. Depending upon that, the equation of the straight line or equation of the intercept form, in the equation of the intercept form of the straight line, that will vary. So that you can check easily by this method, that if you consider 2 point on a straight line, and you can just manipulate those calculations, whatever I have done in this section, and you can get the required answer. But I will suggest that whenever you are given with some intercept for equation and they just ask you that this straight line intercept at this point, and at this point, so you must follow the procedure we have done for this case here. That this straight line passing through two distinct points. So what will be the equation of the straight line? Just remember only one from this one. This one only remember this form and do the calculation, because it may happen that if in different cases Like depending upon the coordinate, the equation of the uh, intersect form may vary and sign can be changed. It should not vary, but except by the sign of the x and y. I mean the coefficient of x and y. So that may be confusing for exam purpose. So don't recall all these different distinct formulas for the equation of the straight line. Just remember only one and try to formulate other formulas, other equations. Next, we will discuss about the distance of a point from a line. Okay, so at least understand that what we mean by the distance of a point from a line. So suppose we have a straight line here and we have a point at this. Now from this point, we can draw many lines to this straight line, like in different color. Yeah, we can draw a straight line like this. We can draw a straight line like this. Like what is this blue straight line? Blue straight line is collection of all points which are along the satisfying the equation of this straight line. Okay, so we are joining any two point of this, like this point, this blue point, and any point on the straight line. We are joining like right now. All these euler lines are giving some particular distance, but what will be the shortest distance from this blue point from this straight line? So the shortest distance from this blue point from this straight line will be the perpendicular one. Okay, so this will be the shortest distance from this point to the straight line. So our main goal in this section is that we need to find the length of this green line. How we can find that will be a method, and for that we will use some concept of coordinate geometry. That is, I have mentioned in the first class, but we should not prove that statements here, but just we will use that statement like where it is. Okay, I haven't mentioned that, so I will mention now, and then I will go. Okay, so like let us type it. This is a formulation of area of a triangle. Suppose I have a triangle. Okay, so it has three coordinates, at least three coordinates it will have, which are the corner points of this triangle. Suppose these are x1, y1, x2, y2, and x3, y3. X1, comma y1, x2, comma y2, x3, comma y. Now the question is, what is the area enclosed by this triangular figure? We need to find this area. So the formula for this area of this triangle will be half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y. So this is the area of this triangle. This is the formula. I am not going to the formulation and the concept behind this area formulation, the area equation. But just remember this fact. Now come to the case where we are going to find the shortest distance between a point and a straight line. Suppose this is our axis. X-axis and x-axis and y-axis, and this is our straight line, which is of the form like ax plus by plus c equals to 0. Okay, and we have a point here, so we need to find the distance. Like, so this is the perpendicular distance of this point to this straight line. So we need to find this. If this point is P, suppose this point is P, x1 comma y1 be the coordinate at this point. So we need to find the distance like P and D. D may be the point of intersection of this. Suppose, just consider. So this will be 90 degree. Obviously, this angle will be 90 degree. Now, this straight line intercepts both y-axis and x-axis. So at which point this line intercept this both the axes? For that, we can rewrite this equation and we can formulate it into intercept form. This one, this will give us minus c. Sorry, not 0. 1. It gives us x equals to minus c comma a plus y minus c comma b. This is equals to 1. So x coordinate, the x intercept position is like minus c comma a 0, and the y intercept position will be 0 comma minus c by b. Okay. Okay. Now look that we can get a triangle like this. If I name it, so this point can be followed by Q, and this point can be followed by P. Okay, so thus we obtain, no, not P, it can be R. So thus we can be obtain a triangle that is PQR. So we obtain triangle PQR, right? And if you know about the what is the area of a triangle, we have a formula here. We have a formula here, and also the area of a triangle is nothing but the area of the base, the length of the base into length of the perpendicular from this vertex, and into the 1 by 2. Like the area of this triangle is, this is a formula, that is half into QR into PD. It is, if it is a triangle, suppose this is our triangle. See, this is the perpendicular from the vertex, so it will give us like half into this length, it will be suppose A, B, C. Suppose this is ABC. Then half into BC into, if this is D, then 8. Okay. So this is the area of this triangle. Now, here also you can see that the PD is the vertical line on the vertical and perpendicular to the basement, and QR is the base of this triangle. So you can write it like this. Now, area of this triangle also have another formulation that we will use. But from here, we can claim that this PD equals to, we can say, 2 into area of triangle PQR divided by Q1. Okay. Now, Q1 means the length of the Q1. Okay, here there is nothing is the vector from this area, or PD, the length of the PD, or Q1 means the length of the QR. Okay, now what is QR? QR is nothing but the distance of these 2 points. So these 2 points of distance like 0 plus C by A 1 square by plus minus C by B minus 0 1 square. So it is squared. So ultimately we get square root of C square by A square into C square by B square. So this will further give us C square B square into C square A square divided by A square B square square root. This will further give us mod of C by AB square root of A square plus B square. So this is our Q1. Now what about our area of this triangle? If I use the formula here, what will be the area of this triangle? Let's find it. Area of the triangle PQ1 is half into x1. X1, suppose it is x1. That x1 can be considered as also x1. So y2 minus y3. What is y2? So suppose our y2 is this one, x2, y2 is this. Suppose, and x3, y3 is this one. So from here, you can write like x1 into y2 minus y3, that is 0 plus c by b, plus x2 means minus c by a into y3 minus y1. And this will give us like minus c by b minus y1 plus what is our y3, sorry, x3. X3 is 0, multiply with something that will be like y1 minus y2, that is yn minus 0. Okay. So this part will vanish, obviously. So we are left with modulus will be there. C x1 divided by b plus c square by ab plus y1 c by a. Okay. So simplify this. Again, we will left with mod of the perimeter will be AB, and this will give us A cx1 plus c square plus bcy1. If I take common, what I will get? Half modulus of c by ab mod of ax1 by1 plus c. So this is the area of this triangle. Now put this in this equation. We know about QR, we know about area of this PQR. Now put these values in this equation. What we will get the PD value? So the PD equals to 2 into half of C by AB mod AX1 plus BY1 plus C divided by QR means mod of C by AB root over A square plus B square. So we cut it. What I will get? Ultimately we get mod of AX1 plus BY1 divided by C by A square plus B square. So this is the length of the shortest length of this point from the straight line. So if you come to this here, so you can clearly see that the coordinate of this point was p x1 and y1, and equation of the straight line was ax plus by plus c equal to 0. So what will be the equation of the shortest distance, that is the perpendicular line from this P to the straight line? That length will be, just put the coordinate of this point P in the equation of the straight line and take the modulus and divide it by root over a square plus b square. This whatever we have done here, this length was like a x1 by1 plus c, take the modulus and divide it by a square plus b square. Okay, so this is the shortest distance, or you can say the perpendicular distance from the point P to the straight line. Okay, now next question comes that what if the straight lines are parallel? Now we can find a distance. Okay, the next point is distance between two parallel lines. So before going to the distance between parallel lines, first note that if two lines are not parallel, then the two straight lines somehow will intersect at some point. At whatever distance, this doesn't matter, but it will intersect at some point, and that's why we can't say that distance between two parallel lines will be some positive number, because at some point these 2 points are intersecting, then that means that the distance between two straight lines becomes 0. But whenever two straight lines are parallel, then they really never intersect each other. So distance can be a positive number. So let's go to the concept behind it. Suppose this is our two axis, x-axis and y-axis. We have two parallel lines, suppose this one and this one. Okay. Now, what is the distance between these two parallel lines? These two parallel lines will be like this, like this. Okay. These are the distance between two parallel lines. Sorry. Now, since the lines are parallel, so the equation have the same slope. both the equation of the straight line will have same slope. So if I write this slope equation like this, then the equation will be of the form either y equals to mx plus c1 or y equals to mx plus c2. Suppose these two are equation of the two parallel straight lines. Here you can see the aim are same because since they are parallel, their slope must be equal. Okay. Now from here, if we consider the equation of the straight line, then we can clearly see that if we put it in the y-intercept form, or you can put it in the x-intercept form, what we will get? Like this will give us y by c1 x by c1 by m minus c1 by m equals to 1 and this one give us y by c2 x by minus c2 by m equals to 2. So from this we can clearly say that this point has coordinates, suppose c1 by m, 0. Now obviously the equation of this straight line will be y equals to mx plus c2. So what will be the distance between them? That will be the perpendicular distance from this point to this straight line. So we have a point on this straight line, and this point is perpendicular distance from this straight line, this blue straight line, this one, right? Now this line will give us the distance between these two parallel lines. So what will be this? You can, if I use the previous formula, we have formulated here, then the distance will be sorry, wait, like red one. Okay, this distance will be if I rewrite this like here, y minus mx minus c2 equal to 0, or you can say like mx minus y plus c2 equal to 0. Then we will be of that form like m into minus c1 by m plus c2 divided by 2 over m square plus 1. Okay, so this will give us c2 minus c1 divided by 1 plus m square. Okay, so if the two straight lines are parallel, then the distance will be like c2 minus 1, which are these constants. These two constants we will consider, and their subtraction, the modulus of their subtraction, and divided by 1 plus m square. Okay. Now, if the straight lines are of the form like, suppose here I have considered for understanding purpose that these are the equation of the straight lines. Now, equation of straight lines can be of the form like ax plus by equals to c1, or plus c1 equal to 0, and ax plus by plus c2 equal to 0. This can be equation of the straight lines. Then the distance between these two straight lines will be again modulus of c1 minus c2 by a square plus b square. And how you can get this? You just rewrite these equations in the form of y equals to mx plus c and put this m value here. Then also you can find the equation of the distance between these two straight lines will be of this form. Okay, so thus we can derive the distance between two parallel lines, and distance of a point from a straight line. In the next class, we will discuss about some examples about this distance of a between two parallel lines or distance of a point from a straight line, like these concepts. And also, we will discuss some more examples regarding this straight lines, concept of straight lines, because of the straight lines like that. And we will try to finish that this straight line chapter in the next class. So let's stop at this point today. And yeah, let's stop at this